My name is Jeric Mabini and I will be performing the week 4 assessment with plotting techniques. The first procedure we need to do is check the reader equipment, which are game and anti-clutter C and anti-cluttering. And as you can see, the game is set to 74%. We can adjust this by clicking it, then move the mouse left or right, and to adjust it then as well as the fantasy clutter and the anti-cluttering. The next is operate the radar option for display, which are north tap and relative motion. Our radar is already set to North Avenue and relative motion, so we can adjust this by clicking which data as many settings, which are head up, course up, and stabilize hip hop. And we have relative motion, which we can set to true motion, but we need to set it to reality module. And next is the on shift, course and distance. Our course over the ground is 0.34 decimal for degrees, and our strands is 0.1 degrees. 903 degrees is next, is at the first observation of the radar, and target obtain the bearing with the use of electronic bearing line. We can see that our electronic bearing line is off. You can set it on there. Our target is 147 decimal 40 degrees. Next, we need to obtain the range of the target with the use of variable range marker, which our BRM is about, and just click it, and we are going to apply the first target, which is 1 knot, because 1.39 nautical miles away from our information. Next is after the first observation, monitor the target for 6 minutes. As you can see, our target is moving and it is changing position, and after 6 minutes we are going to acquire a new position of this ship or target. Our new position is 1.55 nautical miles. Next is at the 6 minute, repeat the procedure for inside which are at the first observation of the radar target. Obtain the bearing with the use of electronic PBL, so we're going to upward the DBL and VRM again of the ship. The EBL change into 285.6 degrees true, and the BRM is now 1.82 nautical miles. The last step is proceed to plot the target data to obtain the relative motion. Right here, as you can see, we don't have a triangle, so we're going to set this EVL1 and set the EVL to acquire new target. Then the intersection between the two targets is our ships. Target data to obtain the relative motion. Right here, as you can see, we don't have a triangle here, so we're going to set this EVL1 and thus EVL to acquire new target. Then the intersection between the two target is our ship's position, and that's all. Thank you.